Hi everybody. In this screencast, I'm going to talk about expected value. What I want to do is specifically go through an application using a probability distribution of a random variable. So in this screencast, we're going to create a probability distribution of the random variable x, and we're going to compute the expected value. So let's consider this example. I'm sure you've all experienced some point in your life where you were asked to buy a raffle ticket. So consider this scenario. 10,000 raffle tickets are sold at $2 each for a local charity. Prizes are awarded as follows: 2 prizes of $1,000, 4 prizes of $500, and 10 prizes of $100. What is the expected value of this raffle if you buy one ticket? So the first thing we need to do is create a probability distribution. So what I want you to think about with this problem is, what are you paying, what are you getting paid out? And what are your net winnings? And what's the probability of that happening? So let's go through it. So the tickets cost $2. And you can win $1,000, $500, or $100. Think about what the net winnings are, because don't forget you have to pay $2 for this ticket. So the net winnings are a negative $2. That's if you buy a ticket and you don't win. The net winnings are $998 if you happen to buy the ticket that wins you $1,000. And the net winnings are $498 if you win the $500 prize and $98 if you win the $100 prize. Do you understand the net winnings? We have to subtract the $2 that you paid for the ticket. So either you don't win, which means you've paid $2, or you have to subtract $2 from your winnings because you paid $2 for the ticket. Okay, now let's look at these associated probabilities. So, whoops. Sorry about that. So the probability of losing $2 is going to be 9,984 out of 10,000. Now, how did I get that number? Well, there are $2,000 prizes, 4 $500 prizes, and 10 $100 prizes. So 10 plus 4 plus 2 adds up to 16. So there are 16 prizes that, 16 prizes. So that means there are 9,984 tickets that end up in no prizes. Do you understand? 16 plus 9,984 adds up to the 10,000 raffle tickets that were sold. Okay, so these should make more sense. 2 out of 10,000 of those tickets are the $1,000 prize. There are 4 $500 prizes and 10 $100 prizes. Once you get this far, I feel like the rest is pretty easy, but you have to really wrap your head around this. A lot of students forget about the fact that they have to pay $2 for the ticket. So look for that in the questions. If you're paying for a ticket, you have to subtract that from your winnings. Okay, so now what we have to do is find the expected value. Oh, before I get there, this is our probability distribution of the random variable. The random variables are the net winnings. So we're assigning these values to x, -2, 998, 498, 98. And these are the associated probabilities for those random variables. Okay, so now we need to find the expected value. Remember, the formula for expected value is you're going to multiply the random variable times the probability of it. So the probability of that happening. So I'm going to multiply these together, -2 times 9,984, etc., and add those together. It's written here. And the expected value is you're expected to lose $1.50. I hope that helps. Email me with any questions.